So right there on the screen is, this is the homepage for the Godot engine. It's just godotengine.org. I should let you know that there's some disagreement as to how to pronounce it. I've heard both Godot and Godot. I was a theater major, so I'm going to say Godot. But I've heard that the people who made it actually call it Godot, so I might be wrong. But why are we using this? It's a really cool engine. A couple of things about it. I'm just going to open it right here. For one, you'll notice it's already open. It took about 4 seconds, which is something you can't say about a lot of game engines. But if I just, I might give you a little preview of what we're going to make actually. A couple things about it. It has built-in 2D and 3D functionality, but unlike a lot of other engines, the 2D engine and the 3D engine are actually separate. So Unity and Unreal, you might think they can do 2D, and technically they can, but it's really just like 2D that's being projected onto a plane with a camera that goes right over it. So you actually have a separate 2D engine in Godot, which is why a lot of 2D game devs like it. A couple of other things, it supports a lot of different coding languages, C#, C++, and it has a built-in language called GDScript, which is very similar to Python. And if you're new to coding, Python is a great language to learn. It's very easy to learn, very easy to read and write. Is anyone who's like brand new to coding here, or maybe never done very much of it? Okay. So Python's a great way to go. GDScript is not exactly like Python, and we can go over some of those differences later. I'm not an expert myself, but I can spot some of those differences for you. Also, Godot is 100% free. And you might be thinking Unity and Unreal are also free, and that's true until you start making money selling your games. So Godot is actually released on the MIT license. It's 100% free. It's even open source. So you can actually crack open the engine and you can modify it and make changes to it. And that's why certain industries, like at least from what I've heard, the casino gaming industry is really interested in it because they don't have to pay any of their profits to companies like Unity or Epic Games, which owns Unreal. Plus you can extend the engine however you want. So yeah, that's Godot in a nutshell. I'm going to close this. If you if you downloaded Godot, now would be a good time to open it. So we're going to start a new project. There's a series of videos on YouTube, or someone I guess who had a video that blew up, and they just said that Godot engine is objectively better than Unity. And he later posted another video saying, look, I was wrong. Here's my nuanced version of that opinion. But then he said that Godot's mascot, which is this little robot, is objectively better, and I do agree with that. All right, so once you have Godot open, and again, it's a tiny program. I think it's less than 50 megabytes. You just click New Project, and you can call it whatever you want. I'm going to call it Platform Game. And you notice it's telling you to choose an empty folder, so I'm going to browse my hard drive, and I actually have a Godot folder already. And I'm going to select that folder, and it's telling me choose an empty folder. I can just hit this Create Folder button, so it'll make an empty folder with the same name. Super handy. The green check mark means you're good to go. Hit Create and Edit. Okay, so when you hop in there, it looks pretty much like any other game engine. You can move around in the 3D space. But we are going to be using 2D, so up here in these different tabs, go ahead and click 2D. And you can use your mouse wheel to zoom out a little bit. And this is your scene view. This is what you see in most game editors. You have your x-axis, your y-axis, and this little blue rectangle is it's like your viewport. It's the size of your game window. So when you play the game, this is the area that you will see. Now that we've done that, we need to create our first node. Godot uses something called nodes, which is similar to objects, if you're familiar with Unity or Unreal. I think they're also called objects in GameMaker. But basically, anything you're going to interact with in the game is going to be a node, or it's going to be affected by nodes. So over here in the scene hierarchy, you can click this plus button, or you can right-click and click Add Child Node. And we're just going to add a normal blank node right here. Hit Create. And go ahead and click that until you can rename it, and we're going to call it World. I'm using a capital W. You don't have to do that, but it's good practice for this. And go ahead and hit Control S to save. It's going to say save this as world.tscn, so that's your world scene. That's what we want to do. So the first node you put in to Godot is automatically like the default name for whatever scene you're in. This is like the master node, for lack of a better term. Okay, now that we've done that, we're going to create a player. Our player is going to be a physics body, so that means he can interact with physics in the space. So to do that, you can right-click this world node and click Add Child Node. And since we know it's a physics body of some kind, you can start typing that in and see what pops up. PHYS, okay. So right now we have a lot of different physics things. These things here in red, those are for 3D games, and you can tell the difference because the 2D stuff is blue, and it also says 2D at the end of it. We're going to use a kinematic body 2D, which if you think of like kinetic energy, like has to do with motion. So kinematic means that you can basically, the user can move it around with input. And you'll see right here, there's this little running character there that lets you know, hey, this might be good for characters. Go ahead and click create on that. And then we'll right click on this kinematic body that we just put in, add another child node, and we're looking for sprite. So you can start typing SPR. There's my sprite right there. And a sprite is just an image in a game. It's just a 2D image. Yeah?
Okay, what was the first one that you did?
Yeah, it's just a blank node. So when you click this plus button up here, it's up at the very, very top. Just says node.
I got it.
Okay. So a sprite is just a 2D image for your game, and it'll represent characters, backgrounds, all kinds of stuff. And right now, our sprite isn't showing anything. You can see it looks like it's about 1 pixel wide if I zoom way, way in here, which is kind of confusing. Little pro tip, if you hold down the space bar, you can click and drag the whole scene view. You can also do that by clicking and moving your middle button if you have one. So with our sprite selected, the Godot icon is always available as a texture in Godot games, which is nice if you need a placeholder, which is exactly what we're going to do. You just grab this icon and drag it over here to texture, which is under sprite. And you can see this little blue box highlights to let you know you can drop that right here. So now we have our little Godot robot right there. And let's see, did we do anything else with him yet? Not yet. One thing to note, so I've got my sprite here, and then if I click the kinematic body, you'll see that they are in the same place, the same square. And you might think if I click in the middle here and I drag him over, I'm dragging both the body and the sprite, but you're actually not doing that. That kinematic body is still over here, and if I move it, the sprite is going to move relative to that. We don't want that to happen, so I'm going to hit Control Z to undo the things I just did. And with your kinematic body 2D selected, you want to click this little button that's right next to this lock icon. And if you hover over it, it says, make sure the object's children are not selectable. So all that means is if I click on this, I'm going to click the parent object, which is this kinematic body, and the sprite will move with it. All right, now that we've done that, we're going to turn on the grid and we're going to turn on snapping, because a grid will let us know that we're putting things exactly where we want them in the game world, and snapping just keeps things nice and orderly. So go ahead and click this little button right here, this little magnet with the 4 dots. That activates snapping. Then you can click these 3 dots right next to it, and we're going to configure snap, like that. And we're going to change grid step from 10 pixels by 10 pixels to 32 pixels by 32 pixels. Make sure you delete what was there before, or you'll be like making it 3,210 pixels. Okay, and then once you've done that, click this View button right here. It just says View, Show Grid. Now we have this nice handy grid, and he always snaps exactly to the grid. So go ahead and put him just somewhere in the middle of your blue rectangle play space right there. Okay. Is there anyone who needs to catch up or is getting lost? Okay. So we're going to add our first script to the game. So we're going to do some coding now. So select your kinematic body 2D, and you can click this little scroll with a plus button right here to add a script, or you can right-click the kinematic body and click Attach Script. We're going to be writing this in GD script. It inherits the kinematic body 2D, and all that means is that this script will be able to use all of the functions and methods and special variables for kinematic bodies. If that makes no sense to you, don't worry about it. So you don't have to change anything, just hit Create. Okay, so this is the built-in script editor in Godot, which is really nice in my opinion. You can use third-party coding editors. I don't see a lot of reason to do that unless you're an advanced user. We think we had 2 people here who are brand new to coding, is that right? Okay. So Python works a little bit differently from things like JavaScript or C#. It's all based on the indentation of your code. And right here, when you see this little hash sign, you are creating a comment. And all that means is that when the computer reads this code and spits it out into your game, it's going to ignore any line that has this hash symbol. So it's a good way to leave yourself notes or to describe what your code does. Or if someone else is going to be looking at your code later, it's a good way of explaining to them how it works. So for example, just here at the top, I could put a hashtag or a hash sign and say like, this script controls movement. And everything else we have in here, we're actually going to get rid of. So everything under that note I just wrote, just highlight it, backspace. Make sure you keep this extends kinematic body 2D. You do need that. So let's see, we're going to set up the physics process because this is a physics object. So we need a function that's going to interact with the physics in this game. So you're going to type the keyword func, F-U-N-C, which is short for function. And then, what did I say? It was called the physics process. So I'll just start typing P, H, Y, and there it is. It's already showing up in the autocomplete. So this is a built-in function, so it finds it automatically. So I can just press enter. It'll type the rest of it out for me. And make sure this little colon is right there. That's important. When I press enter, you'll notice that my cursor has been indented. It's been tabbed in once. So everything that's on the same line is part of this physics process function. So just to give you an example, I could write like, some code, some more code, even more code, and they're all in that same indented line. That means they're all part of this physics process. If I were to press enter and backspace to remove that tab, now I'm in a place where I'm writing a totally new function. So if you have any issues, it should actually give you an error if you try to run code that's improperly indented. But if you're used to things like C# or JavaScript, it's actually a lot easier. Like, I'm not even sure if I remember enough JavaScript, but you might see something like define some function with parentheses, and you'd have an open curly bracket, and then you'd have some code, and then you have to close the curly bracket. You have to make sure that all of your lines have semicolons at the end. You don't have to do any of that stuff with GD script. It's very similar to Python. But you can put semicolons at the end of the line if you want, for some reason. But you don't have to. Okay. So what we need to do with this physics process, this function runs 60 times a second. So basically, every frame of animation in your game, this process is going to run. So this function just monitors your game. And what we're going to make it do is check to see if the user has pressed a button, and if the user has, to apply some motion to this character. Before we do that, we're going to have to create a variable. So above this physics process, I'm just going to make some room right here, and I'm going to create a motion variable. And I'm going to do that by typing the keyword var, V-A-R, and we will just call it motion. We're going to set it by pressing the equal sign, and then vector 2, with a capital V, you'll see that it turned green because that's a special word in Godot. Then an open and close parentheses. So if you know anything about Python, this is different. In Python, you don't have to declare variables. I could have just written, motion equals new variable or something like that. But in GDScript, you have to have that var keyword. So this is a vector, if you're not familiar, is basically just a direction. It's just a direction and a velocity. So we're going to be changing the x and y values of our character using that vector. So in your physics process right here, remember, make sure that you're indented, that one tab. We're going to say if capital I input, and you'll notice there it is in the autocomplete, if I want to find it that way, dot is underscore action. And right here, I'm seeing a couple of different options. Is action just pressed? Is action pressed? Is action just released? We want is action pressed. And you need an open quotation mark. It can be a single or a double, doesn't matter. And we're going to select UI right. So this is a default button in Godot, and UI right is just set to the right arrow key on your keyboard. You can actually change that mapping in the project settings, but we're going to keep it at the default right now. And once you've got all this typed out, make sure you put in the colon at the end, because that tells Godot that this is a new if statement. And when I press enter, you'll notice that it tabbed in one more time. So everything under here is part of this if statement. So if input is action pressed, UI right. If the right arrow key is pressed, we want to change our motion. So we're going to say motion.x equals 100. So all we're saying here is if you press right on the keyboard, the x value of our character should increase by 100 pixels per second to the right. It's just like math class. X increases to the right, decreases to the left. And actually, that should, oh wait, we have to do one more thing, is we need to, we already saved our scene. So right up here, there's this play button. Go ahead and click that. And it's going to ask you, it's going to say no main scene has ever been defined. Select one. Yeah, let's do that. Select. And go ahead and pick your world.tscn. Basically, Godot is just saying that you have to have a main scene. What's the first scene that it should run when you start your game? And look, we have a video game, sort of. It opened, it has graphics, it didn't crash. That's a good start. But when you press right, nothing actually happens. There's a reason for that. Go ahead and close that window. It's that we told it to change this variable, but we never actually told it to apply any motion to this physics object. And Godot actually has a function built in for that. And let's see if we can find it. And we're going to use the help docs to do that. So you can click search help right here. That's one way to do it. And I could start typing in, let's see. Well, this is a kinematic body 2D. So maybe I should learn more about it like that. Another way you can access the help is just by holding the control key on your keyboard and then highlighting any word in your code and clicking on it. So I'm going to click this kinematic body 2D. So here's the help docs right inside Godot. Super handy. You don't even have to open a browser. You don't have to be connected to the internet. It's one of the reasons I like this program. Let's take a look at some of the functions that are available here. Let's see. Get slide collision, is on floor, move and collide, move and slide. That sounds kind of like what we want, right? Because we want the character to be able to move. So let's click that. And right here it says moves the body along a vector. Now if you remember, that motion variable we set up is a vector, so this is exactly what we want. If the body collides with another, it will slide along rather than stop immediately, which basically means if our character were to say like jump and hit a wall, he's not just going to get stuck in it, he'll slide down. So back here in our script, underneath this if statement, but make sure you're not indented and actually part of that if statement, just type move underscore, and there's that move and slide right there. So move and slide, and we're going to put our movement vector in there, motion, move and slide motion, and now hit that play button. Hooray! He moves, but he never stops. And I can't make him go left. So that's the next thing we're going to do. Okay. So under this if statement, go ahead and press enter a couple times, get rid of that tab. So if we made him move to the right by changing the x by 100, can anyone guess how we make him move left? Anybody?
We changed the x by -1.
That's right. That's exactly right. So that was a good guess.
Yeah.
Daniel. So if input capital I dot is action pressed, and this time we're going to say UI left, close parentheses, colon, press enter, motion dot x equals -100. And press that beautiful play button. All right. Class over. Congratulations. You're a game developer now. But he doesn't actually stop. You can make him go left and right, but he's always kind of moving. And you know what? Maybe you find out that would be a fun game mechanic, but we're not going to do that tonight. So now we're checking to see if we're pressing to the right. We're checking to see if the player is pressing left. Now we need to check to see if neither one of those things is being pressed. So we're going to use a new statement. Instead of if, where the second if statement is, we're going to change it to elif, E-L-I-F. That just stands for else if. So if I press to the right, do this, else if, otherwise, if I press left, I want you to do this. And then finally, we're going to do a third statement, else, colon. That's just saying, if any of the other things aren't happening, do something different. I'm going to say motion.x equals 0. My mouse keeps sliding down the screen because it's actually sliding down the podium when I'm talking. It's like it's alive. Okay, so we have this else colon motion.x equals 0. If I'm pressing right, move 100 pixels to the right. Else if I'm pressing left, move to the left. Else if neither of those things happen, make it stop. So press play. Oh, I guess I should close Steam. That would be good. Okay. Left, left, right. Oh man, he moves 2 directions. He stops when I'm not pressing anything. We are making really good progress. All right. So now that we've done all that, we're going to create something for our character to actually move around on. So we have a character, but we need something for him to walk around on. So click your world node here, right click, say add child node, and we're looking for another physics body. So start typing PHY, and down here there's that kinematic body we had before, but our walls are never really going to move. We're not going to make them move unless maybe you were to make moving platforms, but tonight we're going to have static walls, and here's static body 2D. And just like kinematic body 2D has this little running character, static body has what looks like a little wall or a platform, because that's what it's good for. So go ahead and create that. And you'll notice it pops it right up here to the origin, just like it did when we made our kinematic body. And right click your static body 2D and add a child node. We're going to add another sprite. I could start typing sprite again to find it, but it's also over here in the recent nodes that I've added. So anything you've added in your game is going to show up over here, and it could save you a little time. So now with this new sprite selected, once again I'm going to drag this same icon over into the texture area. And just like before, I'm going to select our static body and press this button next to the lock icon. And you might be wondering, okay, this is going to get confusing pretty quick because we have a character and a wall and they look exactly the same. We're going to cheat because it's easier than creating a wall texture. I'm going to click this new sprite that we just put down. And down here in this area, which is called the inspector, if you scroll down to where it says visibility, and then it says modulate, and click this little white square, and you're going to click into this color selector and drag down and to the left. And now we have this lovely black box. All right. Is everyone caught up, I hope? Okay. Okay, so now we've done that, but our character can only move left and right. There's no gravity, so we have to implement some gravity. So we're going to go back to our script. Actually, before we do that, so we don't get too confused, like this kinematic body 2D, static body 2D, it takes a long time to say. It doesn't really say what it is. So let's rename these things. So static body 2D here, we'll just rename that to wall. And our kinematic body, rename that to player. All right, now with the player highlighted, I can just click this little script icon. It'll take me right back to our script. And okay, so when you think about it, what is gravity? Gravity is just a force that's pulling down on us at all times. And it's really depressing when you think about it. But we're going to do the same thing. And just like the X and Y is your left and right values, the Y-axis are your up and down values. Now, in most programming and in most game engines, there's a little difference between what you learned in math class. And that is that for Y to increase, it's actually going down on the axis. So in your math class, you move up, that means Y is increasing. It's the opposite for games. If you want to get into the why of it, it's because the upper left corner of your computer screen is considered 0, 0. So moving down from there is increasing because you can't move up from there. Okay, I got real nerdy and I'm sorry. All right, so in the top of your physics process delta, we're going to press enter to move this UI right if statement down one, and we're going to put something new here. So if I want gravity to be pulling down on this character, what is happening to his Y motion? Can anyone guess? That's right. Good job, Daniel. Okay, cool. So right here at the very top of our physics process, you're going to just hit motion.y. So the Y value of our motion vector plus equals 10. If you haven't seen this plus equals before, all that means is this line here says increase the Y value by 10. And remember, this physics process runs 60 times a second. So 60 times a second, the downward pull is increasing by 10. And that's actually going to create a problem later, which we'll get to. But even just with that, if you press play, see what happens. Okay, he fell down, but he fell right through the wall. Not what we want. All right, let's see if we can figure out why. Okay, well, you'll notice right here, Godot has already been trying to tell us that we're doing something wrong. If you look at your player or the wall, there's a little warning right here. So if you hover over that, what does it say? Node configuration warning. This node has no children shapes, so it can't interact with the space. Consider adding collision shape 2D or collision polygon 2D children nodes to define its shape. So what it's saying is that as far as Godot knows, it has no idea what shape these images are. So it doesn't know how they should interact with each other physically. So we're going to add a child node to our wall. We'll do that first. So right-click your wall, add child node. And what did it call it? A collision shape? So I'll just start typing C-O-L-L-I. Okay, well, there's a collision shape. But those are the red ones. Those are for 3D. So scroll down here. There it is, collision shape 2D. We'll create that. And you notice it puts this tiny little square inside of that one. But if you look over here in the hierarchy, it's giving us another warning. What does it say? Node configuration warning. A shape must be provided for collision shape 2D to function. Please create a shape resource for it. Okay, so I've got this collision shape selected. Let's take a look at the inspector down here. And, oh, right there, shape. And right now it's set to null, which in coding basically means non-existent. So if I click that, and I look for this right here, new rectangle shape 2D. I'm going to zoom in on this so you can see it. So this is where this box will collide with things. And obviously it's not the right size. It should be stretched out to the edges, right? So you're going to grab these handles on the inside and stretch it out like that until it covers all four corners. Make sure that you do not grab these outside handles, because that's just changing the scale of this, and it will actually screw up your collisions.
Is there a way to change it to the 32 by 32 pixels? Just
Like manually, yes.
Oh, okay.
Like like right here in, I think, I can't do it in my transform. I'm sure there is a way to do it manually.
I'm calling you on the spot.
Yeah, you could change the extents.
Oh, yeah.
But now that you've confused everyone, grab these inside handles and just stretch them out to the size of your box there. I'm going to zoom out, and we're going to do the same thing for our player here. So click player, right click, add child node, find that collision shape 2D, or remember it's over here in your recent stuff too, and do exactly the same thing. It's kind of hard to see because they're both blue, but where'd the handles go? Oh, I have to give it a shape. Forgot. So down here in the inspector, new rectangle shape 2D. Stretch it out using those inside handles. Okay. Is everyone with me? You got it? All right, click play. Oh, wrong keys. Yay! But watch what happens when I fall off. Whoa! He falls really, really fast. Like super fast. We're going to get to that in a minute. For now, just keep it in mind. Okay, so now we have the two basic components of any game, right? We have some structures for a character to move around on, and we have a character on which to move them. So we'll take this wall here, and you can just click the wall and hit Control D for duplicate. And you'll notice over here in the inspector, now it says there's a wall and a wall 2. So if I click this wall and drag, you'll see I've actually created another wall. I can do the same thing again, Control D, make another wall, Control D, make another wall, Control D to make another one. Maybe this one I'll just stretch it out. This might mess with our collisions, I don't actually know. Control D, and I would say make at least one side of your level have some height to it, because we want our character to jump up there later. Okay, once you've made a couple walls, you'll notice that your scene hierarchy is getting kind of messy because you have all these walls in there, and we don't like that. So why don't you collapse all the walls that you have here. Looks like I've got 5 of them. And if you click your world node here and you right click and add child node, we're just going to add another regular node. And if any of you have used Unity, this is a trick that you use in Unity a lot. You're just creating an empty node, and we're going to rename it walls. And then I can select this wall, hold down Shift to select my last one, and I can drag all of my walls into this node. And then if I collapse that node, I know all of my walls are in here, but it's not making my workspace really messy. And now just for fun, I'm going to test it one more time. All right. He's moving kind of slow. We'll probably want to change that later. And then I did that super turbo fall again. Okay. So now obviously we need to get him in the air. We need to allow him to jump. So in order for him to jump, we need to find some way to detect if he's actually on the ground, because if you don't, he can just jump in midair forever, which maybe you want to do that for your game. It works for Kirby, but for tonight, we're going to try to figure out, okay, how do we know if he's actually on the floor so that he's allowed to jump? So let's go back into our script, which you can click the script tab up here, or you can click the little script icon next to the player. And you know what? Let's go back into our help docs, because I bet maybe there's something in there. So let's search for help, and kinematic, right there, kinematic body 2D. And let's, in fact, I think I remember something. So is on ceiling, is on floor. That's a Boolean value, which means it's true or false. Let's click on is on floor and see what it says. Returns true if the body is on the floor. It's exactly what we want, and it only updates when you're calling the move and slide function. So that's perfect. I think we'll use that. So you go back to your script, which you'll see right here, this kinematic body 2d.gd. And underneath this last else statement, press enter a couple times. Make sure you remove that tab. And so it was what? Is on floor, right? So if is underscore on, and there it is on floor. I'll just type the whole thing out for fun. Is on floor, open and close parentheses. Make sure you add a colon so it knows this is a new if statement. Press enter. We'll do another if statement. If capital I input dot is action just pressed. So this is different than is action pressed. Is action pressed is just detecting whether or not the key is currently down and currently being pressed. Is action just pressed is listening to see was it pressed at all, and it's going to wait until it's pressed again before it gets triggered. So for jumping, that's what we want. So if input is action just pressed, we'll open up our quote and say UI up. So just the up arrow key. Close the parentheses, put a colon, press enter. And so if gravity pulling us down is adding to the Y value, how are we going to make him jump? Anybody?
Away from it?
That's right. So we're just going to hit motion, motion.y equals negative 400. So his upward motion will take him up at negative 400 pixels per second, but just remember that gravity is always pulling him down at, what, 60 pixels per second. So he'll go up, but then he'll have to come back down. So go ahead and hit play. Let's see what happens. Okay, nothing. He doesn't actually jump. Why is that? Well, let's see. I bet it has something to do with that is on floor. So let's close this. And if we look at our help doc, which should still be open for kinematic body 2D. So is on floor. Remember, it says it returns true if it's on the floor. Only updates when calling move and slide. So let's check move and slide again, see what it has to say. And right here, for the move and slide function, you'll see some different parameters that can go into it. Oh, and here's one right here called floor normal, and it's a vector 2. So that basically means it's a direction. And right here, it says floor normal is the up direction used to determine what is a wall and what is a floor. And it defaults to 0, which is good if you're making a top-down game like Zelda or Pokemon, because everything you run into is going to be a wall of some kind. There is no floor for you to jump off of because the whole world is a floor. So if you're making a side-scrolling game, you basically, Godot doesn't know which way is up. You have to tell it which way is up. So if we go back into our script, and we're going to create a constant value, which is like a variable, but it never changes. And usually you declare your constants before everything else, so put it above this motion variable. And you need the keyword const, which is C-O-N-S-T. And usually when you're naming a constant, you make them all uppercase letters. So constant up, uppercase U, uppercase P, equals vector 2, again with a capital V. And open that parentheses and 0 for the x value, negative 1 for the y value. So basically that's saying like there is no direction to x on either side, but you have negative 1 direction for y, which is that way. So that is what the game now thinks is up. So now in our move and slide function down here, after motion, we're going to put comma and then up. Again, make sure it's all uppercase. And once you've done that, hit play. I don't know why I like that Bob Dylan is playing right now. I don't think he would approve of video games. So he can jump now. Is everyone jumping, I hope? Now, but what's this weird problem? Let's see, if I stay up here for a little while, and I move off to the left, whoa, he falls off really fast. But if I jump off pretty quick, he doesn't fall so fast. I sit here, I sit here, I sit here, and I move off. Woo! Okay, so the reason that's happening is, remember, we're adding 10 to the y motion 60 times a second. So even when I'm standing on the ground, his y motion is increasing forever and ever and ever and ever and ever. So when I walk off of that platform, if I've been standing on it for like 3 seconds, gravity is now what, like 180, and it's going to zap me down really fast. And this is the most programmery part of the evening. This is one of the hardest things to explain why this makes sense, but we're going to take a look at this move and slide function again in our documentation. So if you look at that kinematic body 2D, you scroll all the way down to the bottom. Right here it says it returns the movement that remained when the body stopped. So basically means this function tells Godot, or anything that calls it, like how much movement was left whenever it stops, which should be 0, right? If it hits the ground, it should be at 0. If it runs into a wall, its x speed should be 0. So we have to use that return value. And if you don't understand why this works, I don't blame you. I don't fully understand it myself. But by our move and slide function right here, all the way on the left, we're going to say motion equals move and slide motion up. So at the very end of this physics process, our motion will be set equal to whatever this function returns, which should be 0 if it's on the ground. It's not going to change unless it's falling. And if you press play, you'll notice that, sure enough, I fall very gently now, no matter how long I stay up here. Okay, so that's all the basic instruction for tonight, but now that we've written all this code and we have a functional platformer in, let me remind you, looks like 21 lines of code so far, you're going to want to go back in here and change the game. Like, for instance, he's moving really slowly, right? It doesn't feel right. It doesn't feel good. So if I was just brand new to programming, I might say, okay, well, this motion.x equals 100. That's too slow. I want it to be twice as fast. I want it to be 200. And then I hit play. And the first thing that happens is it starts up, and I move to the right. Oh, that feels a lot better. It moves a lot faster. But I move to the left, and oh, it's still really slow. That feels good. That does. Oh, wait a minute. That's right. I have to change this value right here to negative 200. So we're going to use variables to make this a lot faster. Variables basically let you change your code in one place instead of having to change it in a bunch of different places. It saves you a lot of time and a lot of headaches. So we're going to create some new variables. Let's see. This motion.x is how fast he's moving, right? So it sounds like speed probably. So variable speed equals, we said what, 200 feels good? What other things? Oh, how strong do we want the gravity? I don't want to have to come into this code and change this 10 every time. So I'll create a variable for gravity. We'll keep it at 10 for now. And we also have this right here, this negative 400, which is like the force of his jump. So I might say variable jump underscore force. This is the convention that Godot prefers, but you could also say like jump and then a capital F for force. Either way works. It's just good to, in your code, let people know where there's a break between words if you're using more than one word for a variable. So I'm going to say variable jump underscore force equals negative 400. That seems fine. And now here in the code, instead of using these numbers, these hard-coded numbers, what's up?
Wouldn't it make more sense for those to be constants instead of variables since they won't change in game?
Oh, but, well, yeah, in some ways it might. But for now, we're gonna do it this way for now, though. I'll explain why in a minute. So now that you have these variables set up, you want to get rid of these hard-coded numbers. Hard-coded numbers is like a dirty phrase in programming. Like, you don't want to do that. So for this motion.y plus equals 10, we're going to say motion.y plus equals gravity. And motion.x equals speed. And for moving left, motion.x equals negative speed. And for our jump code, instead of negative 400, we'll say motion.y equals jump force. By the way, the autocomplete also works on variables that you've defined. So when you start typing it out, it will finish it for you. And I don't have to put negative jump force because it's already negative where I declared the variable. All right, so let's see. We set the speed to 200. What do you want to change? Should the jump go higher? Should gravity be stronger? Anybody?
Gravity.
Stronger gravity?
Lighter.
Lighter gravity.
Like, will that work? Like, if you jump, just gonna gradually throw you off the board?
I will probably fly off the screen. We'll see what happens. Okay, so I just set gravity. He's not jumping. Why won't he jump now? Okay, I did something wrong. Jump force equals jump force. What did I do? Did I misspell it? Sorry, jump force. I'm not sure why he's not jumping. If is on floor. Let's try that again. I wonder if the gravity is so light that oh yeah, so it didn't think I was on the floor yet.
Oh.
It's probably like a sub-pixel problem.
Yeah.
Yeah, so yeah, that's too light. We'll increase that to let's do 40. Let's so we've just increased gravity by 4 times what it was before. So I can barely jump at all. This actually feels a little bit better than a big floaty jump, if I'm being honest. But still, even doing that, if I want to change stuff, I still have to go into my script. I have to change the numbers manually. And maybe I want it to be faster, or maybe I'm working with a designer who's not comfortable looking at code. And so I want them to be able to change stuff in the editor itself. So Godot, like a lot of other editors, has some pretty handy functionality for that. So next to each one of these variables we just set, next to this var speed equals 200, we're going to say export and put a space. You notice that turns red. And export gravity, export jump force. And now, if I go back to the editor view, see where it says 2D here? Whoops. If I select my player, now if you look in the inspector, here they are. There's speed, gravity, and jump force. And remember that jump force in the code is jump_force. Godot is smart enough to know that that's 2 different words, so it separates it for me.
What was that called? The function.
Export.
Export.
Yeah.
Okay.
Daniel's real curious about them. So that means that so Daniel is a game designer, and he comes up with concepts, but maybe he's not writing all this code. But he's going to be the one deciding like what feels good in the game, and so the coder, the programmer, can set this stuff up for him, so he can make those changes on the fly to see what feels good. So let's see, that gravity was pretty strong. Maybe I will increase the jump speed or the jump force to like 600. I could also just put in a number, -1000. Press play. And woo! So there you go. Now you have a functional platformer that we made in, gosh, what, like about an hour, pretty much. And it has all the functionality you need to get started. You're going to want to create some actual graphics for it. You maybe want to set some goals for your levels so that it moves on to other levels. And just because Blixa mentioned it, I think I am going to turn these to constants. I think I can still do that. Should still work.
Can you get a bunch of red?
You get red sometimes.
Okay.
No, it doesn't like that. I think there might be another export function that will let that work, but I don't know what it is. Oh, wait. Maybe const int. Might have to define, well, I'm not sure. We're not going to worry about that. But so what is the next step? Now that you have all of these little pieces, if you're trying to learn how to, yeah.
You can export it, the game? Is that what you're talking about?
Well, that would be the next step,
Oh, okay.
but no. I will say that Godot does support exporting to Windows, Mac, Linux, iOS, and I think Android as well.
At the meetup, they were talking about directly into your itch project. So if you have it on itch, it'll connect to your itch and then just automatically update your game.
Is that implemented or is that like coming up? Do you remember?
It's on their website.
Okay.
So I don't know. But I know that was a new feature they were adding.
And I think also WebGL as well, so you could upload it to be played in someone else's browser. So all that functionality is there. I know that at least one Godot game has been ported to PS4. I think it was Deponia was the name of the game. But that requires a lot more effort. But some of the other things, if you're new to making games, some of the other things you might think of are like, okay, so I've got this stuff, but let's take a look at this game, right? For example, like there's no camera to speak of, right? It's just static. It never moves. So your next step might be, okay, how do I implement a camera? And I actually went through this process the other day. I'm going to tell you like 90% of all development, whether it's web development, game development, or whatever, is whatever problem you have and just like Googling it until you figure out how to do it. So, I mean, I could just say Godot camera follow. You can see I already Googled it once. And we've got some YouTube videos that kind of explain how to do it. We've got a Q&A on the Godot forum. Let's take a look at that one. And this is all theater because I've read this before, but we have someone asking, how do I manipulate this camera? And right down here, this guy says, in the editor, create a camera 2D node as a child of the character. On the camera properties, select current. That's it. That's literally all you have to do. So if I right-click this player, add a child node, I search for camera, camera 2D. Okay, now that I have this camera selected, current. Okay, there we go. And like, if this is true, the camera is the active camera for the current scene. Only one camera can be current. So I can just click it right here in the editor. I don't have to do any coding at all. You notice now I have this blue box around my scene. What happens if I hit play? Check it out. I have a camera that follows my player. Not only that, by default, it actually has an offset. It doesn't actually just follow me pixel by pixel. If I get in the center of the screen, it waits until I hit a certain threshold before it starts to follow me again, which is pretty common in most games. And like implementing something like that in like Unity or Unreal would take longer. It would require some coding, at least as far as I know. And we did that just now in like 2 seconds. And now that we've done that, I can show you. So I followed a series of tutorials by a guy named Heartbeast, who's been doing a lot of game tutorials for a long time. Let's see if I can actually find the series I was looking at. Yeah, so this platformer game tutorial series, he's got 7 parts right now. There's more on the way. But these videos are anywhere from like 20 to 30 minutes. Some of them are shorter. Everything I've shown you so far and everything I'm about to show you, I managed to figure out in 2 or 3 days. So just for example here, this is still open. If I open Godot here and I hit project to go back to the project list, yes. And let's see this one. Okay, so using that tutorial series, I'll just show you what all's in there. So just a couple hours over a few days, I have a start menu with functioning buttons. That was on purpose. Great. Did not draw this art, not mine. Totally open source.
Does it take in sprite sheets easy?
Yeah, it does. Very easily. Yeah, so I'll show you some of that too. So this is a tile map that's created this this ground that I'm standing on. You'll notice the background is parallax. It's moving at a different rate than my character. Obviously, we support animated sprites. You know, I have a little, this jump is so hard. Ah! Yeah, I've got a little gate that takes me to the next level, which this one just takes me right back to the first level. But so there's a lot going on here, and this is all running on basically the same code that we made tonight. There's some extra stuff in it. It's harder for you to see it than it is for me to feel it, but there's a little bit of friction involved. You'll notice he slides just a little bit. And he also takes, you know, just a slight amount of time to actually accelerate to top speed. So it feels a little bit more like, say, like Mario or something like that. And you'll see, yeah, you can see him sliding back and forth when I turn around after he's at top speed. So those are just little things you can add without too much more code that make it feel a lot better to play. And then I'll show you something Charles was just talking about. If I go into, let's see, my first world scene here. This is actually kind of tricky to get it running. But when you do, if I select this here, my tile map, check this out. I can put my tiles down wherever I want, and it automatically knows how to stitch them together properly. The alternative to this is to, and you can do this in Godot too, is to have a tile map, which is just a series of, you know, 32 by 32 squares, and you can select the ones you want and paint them on, select the next one that connects and paint those on. Or if you go through the trouble, you can actually set up an auto tiling system like this. It takes a little while. It's not.
You have to make all the art, and you have to make all the borders. But once you make the generic border version, it will automatically be able to put them all like that.
Yeah.
Yeah.
Yeah. So basically, what you have to do is you have to have the artwork, and there is a method to creating the proper number of tiles depending on how big they are. And then once you've done that, you define what's called the bit mask, which is telling the game how they stick together. And then for each individual tile, as far as I know, there's no way to do it en masse. You have to define the collision for the tile so that the game knows that you're not just going to fall through it.
So then every time you do that, so automatically all of the physics.
Yeah, no, because each one of these tiles has like basically essentially one of those collision bodies mapped to it by default. So anything that I just put down right now, I didn't do anything extra to it. Oh. It already works. I don't have to do anything extra. And you know, if you get to that level and you start making different tile maps, maybe you make some that are for background elements that go behind the character, or maybe you make foreground decoration tiles and things like that. So it's for an entirely free program that you never have to pay for ever, even if you make $10 million, it's pretty darn powerful. And I've just been really, really happy with it. And like I said, everything that you're seeing here, I did following some tutorials in a couple of days. I have not messed around with the 3D functionality at all. I mean, like if you go to their homepage, I mean, you can see that it's certainly capable.
So did you do the tile script part?
I didn't do, well, I did do some. The actual tile mapping didn't involve a script. It just involves, you have to, let's see if I have the asset here somewhere.
To the tile sheet.
Okay, so this is another, technically it's another scene. And this is a weird thing that Godot can actually do. My player, who is in this scene right here, the player is himself a scene. You can actually save a scene and instance it inside of another scene, which is a good way to kind of compartmentalize the work that you're doing. So like if you have an artist who's just working on certain art assets, they can have it on their own scene without potentially messing up something that you're doing.
Kind of like layering.
Kinda, yeah. So it's very confusing because you have nodes inside of nodes, and then you have scenes inside of scenes, and it gets weird. But like an example I saw in an article was like, let's say you have a wall with a lot of pipes coming out of it and going back in, that like in Unity you just have to put all those pipe objects in there and fit them properly. But in Godot you could just make individual scenes for different sections of the pipe, and it's it's really powerful, but also very confusing to explain. But like, so this is actually the tile map that was used for this. And let me see. So is that it? What I'm trying to remember is there's a section where you actually have to define what they call the bit mask, and you have to define all of the collisions and all that. I just don't remember.
Is all this explained on Heartbeast?
Yes, it is. And even he is, so auto tiling is new to Godot. It was new in Godot 3.0. And even he's like, it took me a while to figure out how to do this. It's like, I don't really fully get it yet. And I don't think it's even probably fully implemented yet the way they want to, because I'm sure they're probably going to want to make it easier. Because if you look at these individual tiles, like, I mean, that's like one tile. Actually, I think, yeah, so like this is one tile, and I had to go in here individually and say, okay, set the collision for this tile, set the collision for this one, set the collision for that one, and that's,
So where those little squares are?
yeah. In fact, I think the tiles might be 2 by 2. Let me see. Actually, just in the in the Tulsa Game Devs Facebook group, I put up like an overview of making tile maps, and they showed like here's a basic. These are the different kinds of tiles you'll have to make if you want to make a whole set that will connect to each other. So it literally said, just take this and put it into your image editor of choice and just draw whatever you want on top of it and make sure it's the same shape, and it'll work. But that's it. I mean, that's Godot. Like I said, I haven't really messed with the 3D at all. One thing I will say is that there are sample projects you can download. You'll have to go through like downloading a repo on GitHub. And if you've never done that before, that can be kind of daunting.